Hello, my name is Eamon McShane, and today I'm going to be presenting on predicting Pokemon, or why competitive Pokemon is more than just a numbers game. The objective of this presentation and of the modeling involved is to predict a Pokemon's competitive viability by looking at quantifiable data about their mechanical design. To give a slightly more plain text description of what that means, Pokemon competitive viability is determined by tiering. It's a usage-based tiering system. Essentially, the more a Pokemon is used, the better it is assumed to be, because people will generally use the best options available to them, and thus the higher it's tiered. By this metric, we're going to use data about a Pokemon's mechanical design, in other words, nothing about its aesthetic, focusing on stuff that is important to its capacity for battle, to determine how popular a Pokemon would be, how often it would be used in a competitive battle setting. But why does this matter? Pokemon is a franchise for kids, uh, except for the fact that it's the highest grossing media franchise in the world. It beat out the Marvel Cinematic Universe by a factor of 4 times, making 140 billion to the MCU's 35 billion. And everyone knows the MCU is a massive franchise. Pokemon is a huge deal. Anything that has anything to do with it has a huge reach just by how popular and well known it is. More relevantly, though, Pokemon has officially sponsored competitive events. Big ones, including the very recent Pokemon Worlds, have prize pools that in recent times have gotten up to as large as $2 million. Being able to determine whether a Pokemon is good or bad in a competitive setting is a $2 million decision, potentially. With the stakes hopefully established, the data that I'm going to be using to try and make these predictions comes from the comprehensive dataset of all 1025 Pokemon by J. Harmony on Kaggle. It is a 48 column by 1025 row dataset that provides, as you might expect, comprehensive data of all 1025 Pokemon. It provides data about their stats, their height, weight, type, the color they're listed as in the Pokedex, and their various matchups into other types. As for tiers, which will be our targets, that had to be hand compiled by me. I looked on Smogon and specifically their website Pokemon Showdown, which is an unofficial hub that determines a lot of the tiering values, and I compiled it into a Google Sheet which can be found in the slideshow. So what exactly are Pokemon stats? Because these are going to make up a large portion of the data that we use. The other portion is going to be types, which I will explain right after this. This is Pikachu. Everyone knows Pikachu. He's the cute, cuddly mascot of the Pokemon franchise. Pikachu has 6 values next to his picture: HP, attack, defense, special defense, and speed. These 6 values determine a Pokemon's ability to function in combat. HP, defense, and special defense determine the ability to take damage. How much you can take is your HP, and how good you are at not taking it is your defense and special defense. Attack and special attack is how good you are at doing damage. And because Pokemon is turn-based strategy, speed determines the move order of all Pokemon on the field. If you're faster than an opponent, you move before they do. However, the stats that you're seeing here on Pikachu's Pokedex page aren't the full story. They're formulaically determined by what are known as base stats. There are 6 of them, one for each of the actual stats you see here. And then there's also base stat total, which is just adding all of the base stats up. Whereas a Pokemon's actual stats change as it grows, levels up, and travels with you, a Pokemon's base stats remain the same, no matter how long it takes, no matter how long you spend with it. Pikachu's base HP will always be 35, and that value is used to determine how its HP changes as it levels up. These are integers from 1 to 255, and more generally, they fall in the range of about 20 to 160, with really most of them falling in between 40 to 130 for fully evolved Pokemon. From that, you can see that Pikachu is kind of bad at most things except for its speed, which is actually above average. Now moving on to types. Types themselves don't provide a lot of interesting numerical data. They're not that meaningful on their own because one type isn't necessarily any better than the other. Each Pokemon does have one or two chosen from 18 possible types, but what's important is that they determine a Pokemon's defensive profile. Pokemon types have weaknesses, resistances, and immunities. Essentially, a Pokemon's type alters the amount of damage that it takes when its opponent does things to it. If you splash water at a fire-type Pokemon, they're going to take more damage than if you splash water at a grass-type Pokemon. Because fire-type Pokemon don't like water, well, grass types do. It's generally that kind of intuitive nature that determines these type combinations, but some of them are slightly less intuitive. Regardless, what matters here is that you can look at a Pokemon's type or types, compile the individual profiles of those two types, combine them, and wind up with a profile for the Pokemon. And a defensive profile is important for competitive because being able to survive a hit means that you can do more with your time on the battlefield. Now that I've explained roughly what the statistics we're going to be using are, we need to cut down the data frame. There are 48 columns in it. Not all of them are necessary. Really, only about a quarter are. The 11 factors I focused on were the 6 individual base stats, the base stat total, and the number of weaknesses, resistances, immunities, and types that aren't weaknesses, resistance, or immunities at all, known as just neutral matchups. So those 11 pieces of data formed the condensed data set that I used. I then cut rows. There are plenty of Pokemon who are unevolved, and including them in the data set would be like comparing 13-year-olds to 25-year-olds in a fist fight. It's not really that fair. There are some 13-year-olds who could probably hold their own against some 25-year-olds, but most of the time the 25-year-old is going to win that fight. So for the sake of not skewing the data with Pokemon that don't contribute meaningfully to tiers, Pokemon who are untiered, they were dropped from the data set. There are also a couple of outliers, some pictured here, Rampardos, Shuckle, Slacking, Regigigas, that were dropped because they are very poor performing Pokemon that have incredibly high stats in specific areas. Rampardos has a very high attack, Regigigas and Slacking have very high base stat totals. They basically wind up skewing the data too much so that lower tiers would wind up looking better than they actually are in certain metrics. There are some outliers in the opposite direction, but that winds up being okay because we want low tiers to be skewed lower. If a Pokemon is really that bad, it's safe to assume they're just going to be low tier. Once we did this, we standardized the remaining data, changing it on a scale from with mean of 0 and standard deviation of 1. And then as for the tiers, there are 7 main tiers in Smogon. There is ZU, which is the worst tier, then PU, NU, RU, UU, OU, and Ubers, which is the best tier. They were just changed from 0 to 6 so that we would have a numerical metric to use as a target as opposed to strings. Here are a couple of box plots for stats across tiers. We have in the middle, the base stat total. Here you can see some of those outliers I was talking about on tier 0. But on the whole, the medians tend to form a pretty solid gradient, uh, trending upwards, as do the 25% and the 75%, which means that there's generally a good enough correlation here to say outright Pokemon with higher base stat totals are generally going to wind up in higher tiers. And that makes sense. If you have more resources to spend on improving your capabilities, you're going to wind up being a better Pokemon on average. Similarly, here is our box plots for speed, attack, and special attack. This is just to generally show that Pokemon who are capable of dealing a lot of damage with their attacks, and specifically Pokemon who are capable of dealing a lot of damage first with their attacks, tend to get better. It's not a sure thing. There are certainly a couple of Pokemon in lower tiers that are extremely fast, and a couple of Pokemon in higher tiers that are pretty slow. But generally, there's still a general positive correlation with each of these statistics as you go up in the tiers. A technique that I need to talk about before I get into actually any of the results here is oversampling. ZU tier 0, it's a very large category comparatively. It has about 200 entries, whereas all of the other tiers have no more than 80 entries apiece. This is a problem because it means models are going to really favor trying to say 0 or ZU as much as possible, right? If you have a machine that's essentially trying to make guesses, the odds of just getting it right when you say ZU are going to be way, way bigger. Because if you have a roughly 200 ZU samples and a roughly 600 sample data set, that's about a 1 in 3 chance, and a model might just say that's good enough and not actually learn to do anything. So to oversample, I took data points from all of the other tiers and used them to create synthetic data points that were just tweaked slightly in various different parameters, but still functionally the same as other data points, so that you would have the same number of data points in every tier, roughly, and you would avoid your algorithm just saying one thing over and over and over and force it to actually learn. Speaking of, I used a multi-layer perceptron initially. I thought this would be a pretty good idea because a lot of the correlations aren't exactly linear. There are dips, there are dips, there are peaks. A linear fit didn't seem like it was going to actually be that good of an idea initially. That said, the perceptron only really managed to get a cap of about 50% accuracy in my trials on the test set, which isn't that great at first glance. And as you can see, I did 250 epochs of the perceptron, and this is about how long it took for the validation loss to no longer decrease by any appreciable amount. It just stagnated at this point, so I stopped it at 250. But really, this is kind of an inexact science. Pokemon is a game of risks and chances. A 50-50 gamble is pretty okay. Here you have Farigiraf and Brambleghast. These are two Pokemon who had very different journeys in competitive. Farigiraf was a Pokemon that really looked unremarkable at first, but wound up finding pretty niche success because it had a particular combination of attributes that allowed it to shine given what was around it. It didn't look great in a vacuum, but with context, it looked a lot better. Brambleghast kind of had the opposite problem. It looked great in a vacuum. Right? People looked at it and said it had high attack, it had the ability to preempt a lot of other Pokemon, it had a pretty solid defensive typing so it could stick around. and it just never really lived up to that potential. It wound up kind of languishing at the end because it never found a good niche, a good foothold for itself in a higher tier. Pokemon, it's never something that you can predict, but people still took chances on Farigiraf and on Bramblegast because that's what you have to do in Pokemon. It's an inexact science. It's still a science that mostly comes down to trying to figure out what works and what doesn't and adjusting constantly to see if you can make very small improvements over time. And that brings me to the K nearest neighbors and the linear regression. I'm kind of lumping these two together because they did they actually have very similar performances on the test data. They're both used on the basis that similar Pokemon would be in similar tiers, right? If two Pokemon have a lot of the same traits or a lot of very comparable traits, it would make sense they would be in roughly the same, they would be rated roughly the same. The issue with that is similar Pokemon really tend to compete for spots in a tier rather than having sharing the space, right? As you can see here, I have a bunch of water and ground types that have very high HP, solid defenses, solid offenses, and generally mediocre or poor speed. And you have them ranging from Whiscash all the way down in ZU to Quagsire in what is functionally OU. UUBL means that it's too good for UU. It's not officially OU, but it's functionally OU. But what this paints a picture for is that getting a tier exactly isn't really all that important as opposed to getting a general idea of where a Pokemon is going to perform. In a different universe, Whiscash could be the one in NU, Seismitoad could be down in ZU. To some extent, the three are interchangeable. And being able to get something of a slight range is more valuable than being able to get an exact number. If you know a Pokemon is going to fall around PU, it's probably not going to be that good of a Pokemon. If you know a Pokemon is going to fall around UU, there's probably some merit in testing it out. It might be a good OU staple, but even if it's not, it'll find its way into UU probably. And this fixes a lot of the issues with the K nearest neighbors and the linear regression. Both of them really wound up at about 25 to 35% accuracy at finding exactly what you're looking for. But they both got to about 70, 65, 70, even 80% accurate when you gave them a little bit of wiggle room. Getting it just right isn't really the point. To illustrate that, we have Ditto. Ditto is a pretty famous Pokemon. It acts as something of a canary in a coal mine for competitive. Essentially, Ditto sucks. It's not a very good Pokemon. It's rated in ZU. But it finds ways to be useful in just about every tier because all it does is copy whatever your opponent has. If your opponent is bringing something good, Ditto is great. The better the things your opponent is able to bring, the better Ditto becomes. Ditto can kind of fit anywhere, right? Ditto can be Seismitoad in NU, it can be Gastrodon in PU, it can be Whiscash in ZU. Ditto is a Pokemon that defies conventional tiering. There isn't really a good place to put it. This is kind of a summary and limitations. Quantitative data is only part of the equation. This is Pachirisu. By all accounts, its numbers look terrible. It has barely better numbers than Pikachu, and it's fully evolved. But Pachirisu won Worlds. It won one of those tournaments that had that $2 million prize pool. Pachirisu, in a stunning upset, succeeded where theoretically better Pokemon would have failed. There's more to Pokemon than just picking out whatever the numbers say is the best. And I'm glad that I was able to look at the numbers and crunch the numbers, because knowing that there's more than numbers to this is what makes competitive Pokemon engaging and fun, right? That you can try crazy things and see results. And that's why competitive Pokemon can't be just a numbers game. It has to be more, because that's where the thrill and the fun comes from. That's why people are drawn to it. With that, I'm going to conclude the presentation. Here is the collab code if you'd like to look at it. And thank you very much for your time.